Okay, so now that we've done a little bit of work on the definitions of our trig functions here, we're going to use them to actually solve problems. Okay, so let's return to my building example. And remember, what we're trying to do is measure the height of the building, but it's too tall to measure. Last lesson I labeled this theta and the height of the building x. Depending on the building, it might be pretty easy also to measure how far I am away from the building, right? This distance along the ground would be easier to measure than this distance up here, right? So let's call that y. And now I know enough math to write an equation that relates this angle to these two measurements, okay? And in this case, notice I have an angle, and then I have the opposite side and the adjacent side, right? So opposite over adjacent is tangent. So the equation I would write would be tangent of theta equals opposite over adjacent, so x over y, okay? And assuming I knew like maybe y, and I measured this angle, the angle at which I'm looking up towards the building, I could plug those in, and then I could solve for x. So here is where we return to this idea of finding missing sides based on the angles involved in the triangle. Okay. So let's do a couple of examples here. So CDE, measure V is 90 degrees, and then it gives us 12 degrees here for D and the side EC. Okay. So find the length of CD to the nearest tenth of the foot. So CD, it labels X for us. So it's nice that it gives us this picture. So what we have to do is write down an equation involving X. So my task now is to figure out which of my three trig ratios I'm going to use. And the way I'm going to do that is by labeling my side. So for 12, for the angle that I'm giving, 5.6 is the opposite side, and X is the hypotenuse. So then I look at my notes, right, and I think in my head, SOHCAHTOA, sine is opposite over hypotenuse. So sine D would be over H. So sine of 12 degrees is 5.6 over X. Okay. Now I have to solve. Here's where we're going to need a calculator. And I'm going to show you how to do it on the Delta Math calculator, although your TI-84 will be easier. So I hit functions, and then sine, and then I'll hit back, and then I'll type in 12. And I'll get a number like this. These are always going to be big, long decimals. That's okay. So that is my sine of 12 degrees. And I'm going to keep all those decimals. So what I'm going to do is I'm just going to copy it, Control C, and keep that for now. Okay, so, but I'm going to write 0.207 in my work, but I want to keep all those digits just to be precise. And then that's just an equation that you know how to solve, right? So I'm going to multiply times x on both sides to get out of the bottom. And I'm going to divide by 0.207. And here's why it's useful to have that copied. So now I can do 5.6 and then divide it by, and then I can just paste my result there. And then I get my side length, which is 26.93. And we want to the nearest tenth of a foot, so I'm just going to say 26.9 feet. So the couple of keys here, right, as you copy this down in your notes, this comes from a calculator. So I type in my trig ratio in a calculator, and it's like labeling these sides in the drawing is going to get you where you need to go, because that's going to help you pick which ratio you're going to use. We're going to do a cosine example and a tangent example here, but make sure you understand this one and have it down in your notes before you move on. Okay, here we have an example. We're looking at angle B this time. Take a second, think about which ratio we would use here, and you can use your notes about their definitions to help you. Okay, so remember our mnemonic is SOHCAHTOA. And cosine is adjacent over hypotenuse. So here we'd use cosine of b equals 5.7 over x. This, by the way, like, you can write this on your paper whenever you need it for the rest of your math career. This will always be helpful in dealing with these trig ratios. So this is like sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And you say SOHCAHTOA, and you will never forget it now from this point. Okay, I'm going to plug in my givens here. So 79 degrees, cosine of 79 degrees equals 5.7 over x. That I'm going to type into my calculator, and then I'm going to solve it, right? So cosine of 79 degrees, you're going to get 0.19 and a bunch of decimals equals 5.7 over x. And then 0.19x equals 5.7. And then my result rounded to the nearest tenth is going to be x equals 29.9 feet, I believe. Okay, so there's your cosine example. Next we're going to do a tangent. The setup, once you have them set up, the solution's always the same. Okay, so here's our tangent problem, and I already told you it was a tangent problem, but the reason I know is A is my angle given, and then I don't have a hypotenuse, right? So I have 6.6 is my opposite side and adjacent side. So I'd say tangent of A is the opposite over adjacent, which is tangent of 78. And I would say 6.6 over x. Right? And then tangent of 78, you're going to get 4.70 and a bunch of decimals. Keep all those decimals. And your solution when you divide it out is going to be 1.4 feet. I rounded that to the nearest tenth. So make sure you have all these examples captured, and once you have them set up, it's pretty smooth going, so make sure you pay close attention to the setup, which ratio you're picking, and then the solution's always the same from there.